you've had enough time to have a little conversation? I heard some good comments and some interesting things. I don't have any idea. So let's talk about it just for a minute. We're not going to spend a lot of time on this, but I just want to make sure that it makes sense and that our time together on Friday was not lost into the ether. So, what is radio astronomy? Does somebody have an answer? Or should I just call on people? Don't call on me. Go, yeah.
It's like taking pictures of satellites that like emit radio waves that will come back and like render pictures so you can see it.
Okay, so we're going to take pictures. And then I missed the next part. What'd you say? Take pictures?
Using like radio waves.
Using radio waves. Instead of what? As opposed to visible, which is what we usually think of. Not visible light. Because remember we talked about how everything glows, right? And everything glows in different parts of the electromagnetic spectrum. Right? We talked about this a long time ago. You know, when I told you that there were those awkward people when I was pregnant that would say, "Oh, you're glowing," right? And you're like, "Thanks, that's weird." And then, like, the physics brain in my brain says, "I am glowing." Yes, indeed, I am glowing. I'm glowing in the infrared, but you are too, right? So there are things that are, I have a question for you, warmer or cooler than things that emit primarily invisible? Is it going to be warmer or cooler if they're in the radio part of the spectrum? Cooler, yes. We're looking at cooler things. If you think about it, I'm looking back at this EM spectrum that's taped up on the wall up here. So you look at visible light, right? That's the one that we think about. That's when we think about all the light coming that we see, naked eye. And we look at this really lovely rainbow on the bottom. Purple is going to be high energy, right? High energy, warmer, more energy, okay? Red is lower energy, cooler. And then if you go to infrared, that's even cooler, and microwaves even cooler, and radio waves are even cooler. So if we're looking at things in the radio wave, we're looking generally at objects that are cooler than things that are glowing primarily in the visible part of the spectrum. So it is pretty cool, isn't it? Yeah. So we're taking pictures using radio waves. So we're looking at different objects or different aspects of the same object. Because even our sun that emits so much in the visible part of the spectrum emits also in infrared and in microwave and in radio wave. It emits in all of those parts of the spectrum, just primarily for us in the visible part of the spectrum. Which one are you trying to read? Aspects of the same object. Yeah. Okay? So we're taking pictures using radio waves to look at different objects, different aspects of the same object. So that would be an advantage for radio waves or for radio astronomy. What's another advantage for radio astronomy? Beth, what you got?
It doesn't need to be dark.
It doesn't need to be dark outside. Absolutely. You can take images at any time, right? Any time of the day or night. When I was in college and I loved astronomy. I did a lot of astronomy, but there were definitely students that were my classmates who were really into astronomy. Okay, in particular, I had two. One was named Katie and one was named John. And John was really, really into he was into like looking through telescopes and taking images of telescopes. And he always had to be up super late because he always had to be out at the scope when it was nighttime so that he could see things. My friend Katie, they're both now like professional astrophysicists. Katie was a radio astronomer. And so she collected a lot of data in the radio part of the spectrum. And so she was able to have a much more normal college existence, if you know what I'm saying, because she didn't have to be up late at the telescope taking data all the time. Okay, because she was doing research, but she was doing research that came from a radio telescope. So it came in during the day. She got her data during the day. She still does. She still does radio astronomy. It's pretty awesome. Anyway, so you can do it any time of the day or night. Why? Because you don't have to have visible light coming not from the sun, right? It's that sun just gets in the way. Yeah. So you don't need the sun to be down, we'll say. Because those radio waves are going to come in all the time. And they will interact with the radio waves from the sun, but we can subtract those out pretty easily to know what we're actually looking at. Question? That was you're going to ask? Gotcha. Yeah, and that's something that you have to do regardless of what kind of light you're looking at, right? And you have to subtract out whatever from other sources. Kind of like, do you remember when we were talking about the evidence from the Big Bang, right? The cosmic microwave background, and they had to clean up the pigeon poop, right? Do you remember that whole thing, right? They had to clean up the pigeon poop because they were afraid that the poop was, that sounds so gross, but emitting microwaves, which it probably was, okay? And so they had to get rid of that extra information so that they could just look way out at the universe. So I think we talked about this on Friday as well, but I just wanted to reiterate to you the pictures, right? Next time you're out on Coralville Lake, if you and your family are boaters, keep an eye out for this radio telescope, right? This is part of the Very Large Baseline Array. This is in North Liberty. Had my head at college there, okay? And it's part of a telescope that spans the entire continent. One telescope. It's pretty cool. It really is. All of them are pointed in the same direction, to the same area of the sky. And so they get images from using all of those telescopes together. Okay? Yeah.
Where are the ones on the bottom?
We can scroll down. Texas, New Mexico, Virgin Islands, and Arizona. Yeah. Pie Town. I kind of would like to go to Pie Town. Yeah, whatever Pie Town. I bet they have. I know, right? And it's PIE, so it's got to be good. Pie Town. I'll have to do some research about Pie Town. I'll let you know what I find out. Yeah. Well, the VLA, this whole set of telescopes is in New Mexico. So my guess is that it's pretty easy for them to get it set up. I don't know if you've ever been to the Southwest, but it's pretty desolate, pretty barren. There's not a whole lot there. So it's a whole lot easier to find a spot to put a telescope. Whereas in Iowa, land is a hot commodity, right? For farms and things. So it's harder to find spots for things. Yeah.
I ran across country in New Mexico and it was just a flat land and there was nothing.
It's pretty boring. I have a cousin that lives there, so we go visit pretty often. But yeah, it's definitely not Iowa. Let's just put it that way. It's beautiful in a different way. Okay, I love Iowa though. I think Iowa's beautiful. I ride Ragbri every year. Don't say you're gonna poke your eye. Oh my gosh.
Poke my eye out.
You totally are, and it's gonna be bad. I don't want that. All right. Questions you have? Shh. Before we get started. Okay. Cool. We are